My dear students, in this video I am going to find out the angle between the two planes. If the two planes r dot n1 equal to d1 and r dot n2 equal to d2 are the two given planes, and we have to find out the angle between these two planes. This is plane 1 and this is plane 2, r2. R dot n2 equal to d2 is plane 2. We have to find out the angle between these two planes, r1 dot n1 equal to d1 and r dot n2 equal to d2, r dot n1 equal to d1, where r is the position vector of a common point where the normals drawn to these two planes. R is the position vector of some common point P to both the planes. The common point is defined by the vector OP vector. The position vector of the point P is OP vector, that is given by R vector, which is equal to XI vector plus YJ vector plus ZK vector. And N1 and N2 are the normals to the given planes. N1 is a normal to the plane 1 and N2 is a normal to the plane 2. And let theta be the angle between these two normals drawn from some common point P. Theta be the angle between the two normals to the planes drawn from some common point P. So angle between the two normals drawn from a common point for both the planes is theta. But that we have to find out. The angle between the two planes is theta. We have to find out. That is given by the formula cos theta equal to n1 modulus of n1 dot n2 by modulus of n1 into modulus of n2. This is the formula for finding angle between the two planes. Cos theta equal to n1 dot n2 by modulus of n1 into modulus of n2, where n1 is given by the vector a1i plus b1j plus c1k and n2 normal vector n2 is given by a2i plus b2j plus c2k. The normal vectors are defined by the direction ratios a1, b1, c1 are the direction ratios of normal vector n1 and a2, b2, c2 are the direction ratios of the normal vector n2. So that's all about the concept angle between the planes. Cos theta equal to modulus of n1 dot n2 by modulus of n1 into modulus of n2, and n1 and n2 are the normals drawn to the both the planes. N1 is a normal drawn to the plane 1 and N2 is a normal drawn to the plane 2, drawn from some common point. Angle between those two planes is theta. Suppose N1 dot N2, we have determined this angle between these planes by Cartesian form. We have to find out the angle between the planes is given by cos theta equal to n1 dot n2 by modulus of n1 into modulus of n2, you know. So by Cartesian form it is defined by cos theta equal to n1 dot n2 See, again angle between the two planes cos theta equal to n1 is a1i plus b1j plus c1k, a1i vector plus b1j vector plus c1k vector dot n2 vector is a2i plus b2j plus c2k by mod of a1 is root of mod of n1 is a1 square plus b1 square plus c1 square into modulus of n2 vector is a2 square plus b2 square plus c2 square. See, n1 dot n2 is a1i plus b1j plus c1k dot a2a plus b2j plus c2k divided by denominator mod of n1 is modulus of n1 is root of a1 square plus b1 square plus c1 square, and modulus of n2 is a2 square plus b2 square plus c2 square. This is called partition form to find out the angle between the line. So this is equal to I dot a1, therefore you will get a1 b1, a dot j1, a1 a2, sorry. I dot a1, therefore a1 a2, j dot j1 plus b1 b2 plus c1 c2, k dot k1 by plus c1 c2, a dot n1 dot n2 is I dot I1 a1 a2 plus b1 b2 plus c1 c2 divided by the denominator value is root of a1 square plus b1 square plus c1 square and root of a2 square plus b2 square plus c2 square. Denominator is, as in the case of previous steps, the same denominator. You will get a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. This is theta, cos theta. Theta equal to cos inverse. You can write that by theta equal to cos inverse of this quantity. From this we can determine the angle between the two planes theta. Conditions as remarks. If the two planes are perpendicular, if the two planes are perpendicular, that means angle between the two planes is 90 degrees. If the two planes are perpendicular, then we know that n1 dot n2 equal to 0, or this is otherwise new n1 dot n2 a1 a2 plus b1 b2 a1 a2 plus b1 b2 plus c1 c2 equal to 0. This is the condition for the two planes are perpendicular. And if the two planes are parallel, second condition is, if the two planes are parallel, then the direction ratios are proportional. Then the direction ratios of n1 and n2 are proportional. Then the direction ratios, then the direction ratios of n1 vector and the n2 vector are proportional. That is, if the parallelism of the two planes implies that the two direction ratios of n1 and n2 are proportional. That is, a1 by a2 equal to b1 by b2 equal to c1 by c2. This is the condition for the planes are parallel. If the planes, angle between the planes is 90 degrees, then the dot product of two normal vectors n1 and n1 dot n2 is 0. And if the two planes are parallel, their direction ratios are proportional. Okay, now we will solve one problem. Find the angle between the planes. calculus problem. Find the angle between the planes. Two planes are given. That are 2x plus y. 2x plus y minus 2z equal to 5. This is plane 1. And plane 2 is 3x. And plane 3x minus 6y minus 2z equal to 7. This is plane 2. Find the angle between these planes, two given planes. First plane can be expressed as r dot 2i vector. You can replace x, y, z by I, j, k. 2i vector plus j vector minus 2k vector. Equal to 5. This is plane 1. And second plane r vector dot 3i vector minus 6j vector minus 2k vector equal to 7. These are the two given planes. R dot n1 equal to d1, R dot n2 equal to d2. These two planes are given in the form R dot n1 equal to d1 and R dot n2 equal to d2. This is n1 vector and this is n2 vector, this is d1 and d2. Now to find out the angle between the two planes, cos theta equal to modulus of n1 dot n2 by modulus of n1 into modulus of n2. So straight away we have applied this given data into the formula, angle between the, therefore, angle between the planes, angle between the given planes is cos theta equal to n1 dot n2 by modulus of n1 into modulus of n2. The entire thing is given into modulus. Therefore, cos theta equal to n1. This is first vector, first plane containing n1, that is 2i vector plus j vector minus 2k vector. This is n1 dot n2 in the second plane, 3i vector minus 6j vector minus 2k vector. This is n1 dot n2 by modulus of n1 is root of 2 square plus 1 square minus plus 2 square. Squaring is become minus become plus on squaring. Similarly, modulus of n2 3 square plus 6 square plus 2 square. So this is equal to I dot a1, 2 3s are 6, j dot j1 minus 6 and minus plus 2 2s are 4 by root of 4 5 plus 4 9. And this is 9 36 plus 9 45 plus 4 49. So this is equal to 4 by 3 into 7. This is cos theta. So angle between the planes cos theta equal to 4 by 21. 3 sevens are 21. From this I will get theta equal to cos inverse of 4 by 21. That's all about the problem. So angle between the two given planes is cos inverse of 4 by 21. That's all about the problem. Okay? And one more problem. show that the two planes are perpendicular. Next problem, we have to prove that the two planes are perpendicular. Show that the two planes are perpendicular. The first plane is 2x plus y plus 3z minus 2 equal to 0. Another 2x plus y plus 3z minus 2 equal to 0. Another plane is x minus 2y plus 5 equal to 0. X minus 2y plus 5 equal to 0. This is plane 2. We have to prove that these two planes are perpendicular, and you have to rewrite these equations of the plane into the standard form, vector form, r dot n1 equal to d1 and r dot n2 equal to d2. After that, if the two planes are perpendicular, then r dot of n1 and n2 is 0, we have to prove. Okay. See, this is first plane is r dot 2i plus j plus 3k equal to 2. This is plane 1. And second plane is r dot I minus 2j equal to minus 5. Plus 5, if you bring it to the right hand side, it is minus 5. So this is n1 and this is n2. Therefore, if the two vectors are perpendicular, if the two planes are perpendicular, we have to prove that n1 dot n2 equal to 0. What is n1? 2i plus j plus 3k dot n2 is I minus 2j. That is equal to I dot I1, therefore 2 into 1, 2, plus into minus minus j dot j1, minus 2 into 2, minus 2, that equals to 0. So this is 0, 2 minus 2, 0, therefore the two vectors are perpendicular. Since n1 dot n2 is 0 implies, therefore, taking dot product, I dot I1, 2 into 1, 2, j dot j1, plus into minus 2. There is no k here, therefore you leave it. This is 2 minus 2 is 0, therefore the two planes are perpendicular. Therefore the two given planes are proved perpendicular. That's all about the problem. Okay. Next, similarly, we have to show that the given two planes are parallel. See this problem, show that the two planes are parallel. Next problem is the two planes are parallel, 2x plus y. First plane is 2x minus y. 2x minus y plus 3z minus 1 equal to 0. Second plane is 2x minus y plus 3, show that the two planes are parallel. Problem is show that the two planes are parallel. For that, the first plane is 2x minus y. 2x minus y plus 3z minus 1. 2x minus y plus 3z minus 1 equal to 0. This is plane 1. And next plane is plane 2 is 2x minus y plus 3z. Second one is 2x minus y plus 3z plus 3 equal to 0. So you rewrite these two planes into the vector form. R dot n1 is R dot n1 is 2i minus j plus 3k equal to 1. Similarly, second vector, second plane is R dot n2 2i minus j plus 3k equal to minus 3. We know that if the two planes are parallel, we know that the direction ratios are proportional. If the two planes are parallel, the direction ratios are proportional. If the two planes are parallel, the direction ratios of normal vectors n1 and n2 are proportional. That is our condition. If the two planes are parallel, the direction ratios of n1 vector and n2 vector are proportional. So n1 is this 2 by 2 a1 by a2 equal to b1 by b2 minus 1 by minus 1 equal to c1 by c2 3 by 3. All are equal to 1. 2 by 2 minus 1 by 1 3 by 3 equal to 1. Therefore the direction ratios are proportional. Therefore the two planes are parallel. Therefore the two planes are parallel. This is a1 b1 c1 a2 b2 c2. a1 by a2 is 2 by 2. b1 by b2 is minus 1 by minus 1. c1 by c2 is 3 by 3. They are proportional, hence they are two given planes are parallel. That's all about the problem, and I will stop the video here. We will continue the remaining in the next video. Thank you.